All right, so this is the problem set for the week of April 27th, and this is problem 6 that I'd like to go over. It says if S is a 2012 by 2012 square split into unit squares, a diagonal of S will pass through the interior of 2012 unit squares. If R is a 2012 by 2015 rectangle split into unit squares, a diagonal of R will pass through the interior of how many unit squares? So let's break this down a little bit and see if we can make sense of it. So let's first understand why a 2012 by 2012 or an n by n square will go through n squares. So here we have a 3 by 3. We can see that the diagonal is going through 3 squares, and that of course is because in a 3 by 3 square, the diagonal is going to go through the vertices of each square along the diagonal, and there are 3 diagonals here. So in a 3 by 3, it's going to go through 3 squares. And I think we can generalize that to, in an n by n, it's going to go through n squares. So one connection we might make that'll help us for this problem is notice that the slope of this diagonal line is clearly 3 over 3 or 1 over 1, right? So if we can figure out how many squares, how many unit squares a diagonal goes through in a 1 by 1, we can just scale that up by 3 because dividing by 3 here is what gave us the slope, and that's telling us that there are 3 1 by 1s along the diagonal of a 3 by 3. But clearly the diagonal of a 1 by 1 is going to go through precisely one unit square. Okay, so the idea here is that if we can analyze a 1 by 1, and then we can scale up to a 3 by 3 by multiplying. So obviously in a 1 by 1, the diagonal is going to go through exactly 1 unit square, and then if you just, since there are 3 of those, you multiply by 3. So that'll help us in the next version of this problem. So here's a situation where we've got a 6 by 4, okay, and 6 and 4 are not relatively prime, okay, so that's how we're going to attack this. So the slope of this diagonal line here would be 4 over 6, which reduces to 2 over 3, and if you divide the numerator and the denominator by 2, you get this 2 over 3. So the idea is now we're going to analyze a 3 by 2, and if we can figure out how many unit squares the diagonal goes through in a 3 by 2, then we're just going to scale up by 2. So in the picture here, you can see that the diagonal is going to go through a lattice point here exactly when it's gone through a 1 3 by 2 block. So let's just count for now. In a 3 by 2, it goes through 1, 2, 3, 4. So in a 3 by 2, it goes through 4, and now we're going to scale up by multiplying by 2, the thing we divided by up here, to see that in a 6 by 4, okay, it goes through 8. Okay, because it's going to go through a 3 by 2 twice. Once here, and then meet at the lattice point, and then it's going to begin again. let's take a look at a situation when the length and the width don't have any factors in common. So let's analyze this 5 by 4 rectangle. So if you look at the slope is 4 over 5, and that's as reduced as it can be, which means that we can't really scale it down and then analyze it as a smaller problem and then scale back up. This is as small as it gets. So we need a different way of thinking about it, and that's what we're going to do here. So the thing to notice is that these are lattice points, where the diagonal begins and where it ends here. Those are lattice points, and this diagonal is not going to go through any more lattice points in between the beginning and the end. Okay, it happened in the previous example, but that's because the dimensions were not relatively prime, but here they are. And so a good way of thinking about how many unit squares this diagonal goes through is to notice that to get from the bottom left to the upper right, it's got to pass through 4 horizontal lines. Sorry, vertical lines. And then 1, 2, 3 horizontal lines. And every time it passes through a vertical line, it's entering a new square. And every time it passes through a horizontal line, it's entering a new square. So let's first begin with the fact that it's immediately going to enter the first square. So it starts already going through 1. And then it's going to go through 1, 2, 3, 4 vertical lines. And it's also going to pass through 1, 2, 3 horizontal lines. Okay, and that gives us a total of 8 squares. So let's just check that by counting. So I did the first one, here's another one, 2, 3, 4, 5, 6, 7, and 8. So let's see if we can generalize. This 4 here is 1 less than the base of the rectangle, so I'm just going to put a 5 minus 1, and the horizontal is 4 minus 1, which is 1 less than the height. So let's see if this works on another example, and then we'll solve the initial problem, which is All right, so let's try that on this rectangle here. This is a 7 by 3. Okay, let's just, before we even count, let's just try our little rule here. So we have 1 unit square for the first, the bottom left one, and then it's going to have to go through 7 minus 1 vertical lines plus 3 minus 1 horizontal lines. So that gives you 1 plus 6 plus 2, which is 9. All right, so if our rule works, it should be going through 9. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's reassuring. It looks like it works on the smaller example. So I think now we have the tools to actually solve the main problem. All right, so here's that problem again. We're trying to find how many unit squares the diagonal of a 2012 by 215 rectangle will go through. So the first question we ask is, are those relatively prime? And with a little examination, I think you'll see that they are. So what that means is we can use our rule. So we're going to do 1 for this bottom left rectangle it's going to go through. And then we're going to do 2012 minus 1 plus 2015 minus 1 to give us, so again, this would be the number of vertical, this is the number of horizontal lines that would go across. So this is 1 plus 2011 plus 2014, which is 4,026.